After we received the equipment, take out the instrument. Then take out all the accessories. Confirm the accessories first. First we can see the light guide arm. Light guide arm, pulse head. The key. Pulse head, F equals 100. Light guide arm wrap with buckle. There are also replaceable pulse deflectors. Here, by rotating this, we can replace with the gynecologia treatment header. The lenses for gynecologia treatment head. 90-degree head. 360-degree head. The plug. Eye mask. Foot switch. Dot matrix head. After we get the light guide arm. First, open the dust cover. Look at this pulse head. Please pay attention, they are two parts together. The parts of F equals to 100. This part are together. If you need remove it, you have to take this part off together, not just the lower half. Now we start to install them. Then take the light guide arm by our hands. You need to turn it with a 90-degree bend here. Just do turn around like this. You saw it had turned around. This light guide arm can be installed now. Pick it up now. When installing, we open the dust cover first. There's a screw here. We can twist it out with our fingernails. After twisting it out, let it bulge out. If it protrudes, you can install the light guide arm in it. Then screw this screw in. Then open the multi-core aviation plug. There is a reminder label here. We must look at this label. When we disassemble anything, be sure to look at this label. This label indicates that this line cannot be taken out when the machine been powered on. If you want to plug and unplug, be sure to turn off the equipment firstly. We plug it in now. Let's install the light guide arm first. Remember to keep the light guide arm in vertical. If it is not vertical, if you bend it at an angle, it may not fit in. After installing it, we tighten this screw. You can use your fingernails to make the arm been installed in vertical. The light guide arm will be more stable. Now we install the dot matrix head and take this wrap tape. First, we need to put the dot matrix head. Be careful to protect it, don't fall to the ground. Then we straighten the pipe. We must seize this dot matrix operation head. Find the corresponding position and insert it. We can see that there is a bayonet here. After we got in, to tighten the knob in blue part. Then we check it if it will be loose. If won't, it's fine. Then we see that there is a trachea on the dot array head. This end is already connected. Then we get the other end. The other side of the. When we connect this trachea, we have to take this tracheal nozzle off first. Put it into the trachea. Then cover it back. Put it on the gas nozzle. Tighten this lid. After tightening, we see the dot matrix head has a red cover. We pull it apart. Straighten the pipe. We install the dot matrix head on the light guide arm. Let's roll it up. We'll leave enough for this side. Operate the activity space here. The rest we can go to the back. On this side of the surface we can connect. This wrap can be used repeatedly. It's no problem to peel it off and stick it on. Now we completes the installation. After turning on the main switch at the back of the instrument, we then loosen the emergency stop. Once loosened, we gently turn the key clockwise to open it. Now, let's take a look at the interface. This is the main interface. And we click on the Enter button on the right side. After entering, we can see two modes: Pulse mode and Matrix mode. First, let's look at Matrix mode. In Matrix mode, we use the matrix operation head. The output from the matrix operation head has a fixed shape of 10 mm by 10 mm, which is equivalent to 1 cm by 1 cm. This shape and size are fixed. Returning to this interface, the options 7 by 7, 9 by 9, 12 by 12, 15 by 15, 18 by 18, and 20*20 represent this fixed shape. Within this fixed shape, the number of points and columns can vary. For example, there is a 9 by 9 option and an 18 by 18 option. Next is the density selection within the fixed shapes. We can choose one at random. After entering the operation page, we first look at the left column. This column includes folders for skin rejuvenation, acne treatment, wrinkle removal, fine lines, and a sequence option that is set to default and does not need to be changed. We see 4 folders that we can set according to our usual usage habits to adjust parameters suitable for our use. Once set up, we can proceed. After clicking into this interface again, we can obtain the basic parameters we want and make adjustments as needed. Now let's discuss the right side, where we set up if we need to configure the skin rejuvenation mode. We click to begin setting it up. First, we'll explain how to select on the right side, without going into settings yet. Here we can see units in mJ, millijoules, which indicates energy levels, with low, medium, and high settings, available for multiple pulses or single pulses. Looking at millijoules represents energy. This energy has low, medium, and high settings. Currently, I am at the lowest setting with a maximum value adjustable to 100. In medium it can reach up to 250. And in high it can go up to 400. Typically in our usage, such high levels may not be necessary. So we start from lower settings. The number of outputs refers to how many times we want to output within that square. Once or multiple times. Up to 4 times or even 20 times. If kept stable in one position. The multipulse option indicates that it will output points faster, while single pulse means it will output slightly slower. To demonstrate this, first take an A4 sheet of paper and fold it twice to create 4 pages. Then we use a foot pedal for control and switch on for light activation. Initially, we will use 5 watts power with multipulse output working. This means fast frequency output. We see that this shape is fixed. If we select a 9 by 9 configuration first, it outputs 9 points by 9 points. We can verify on the interface again that it's indeed set to 9 by 9. Now looking at single pulse output. Working slightly slower allows us to adjust our capacity, visibly demonstrating energy levels. 1 sheet of paper corresponds roughly to 5 watts. About 1.5 sheets thick. And after visualizing this energy applied onto an operator's skin area, this energy clearly penetrates deeper and stronger with 1 sheet. Compared to 2 sheets or 3 sheets, by 4 sheets, the imprint is weaker. Let's define this as 3.5 sheets thick. If higher energy is needed, adjustments can be made accordingly. Single pulse will output slower, while multipulse will speed up. Next, returning to check other point quantities, while maintaining 40 watts with a selection of 12 by 12 points, leads us to complete penetration. Here I only selected 4 sheets, so we don't not increase energy further. You can test higher energy if have more paper sheets. The pulse head is set to F equals 100. When installing this pulse head, you start by unscrewing it from this position. You can see a dividing line at this location. Unscrew it between the two silver dividing lines to separate them. Once separated, you can remove any clips or waistbands. However, it's crucial to note that the aviation connector must remain connected. Do not remove the aviation connector. Keep the blue aviation connector in its original state. Next, we will attach the pulse head. Align it properly and then proceed to rotate it. Once secured, this is how the pulse head is installed. Let's first discuss the pulse modes, which consist of 3 different modes, referred to as Pulse 1, Pulse 2, and Pulse 3. Pulse 1 has more options available. Among these options, we can see the first, third, and fourth settings. First, aesthetic surgery. Third, ear, nose, and throat procedures. Fourth, general surgery. The adjustments for these 3 settings depend on the intensity required by the physician. You can also set the laser start and end times accordingly. Power settings. The power can be understood as ranging from 1 watt to 40 watts, allowing for a broad adjustment range based on your specific needs. Understanding laser start and end times. The laser start time refers to how quickly the output occurs. A smaller value means slower output. When the start time is small, the output is slower. When it's larger, the output is faster. For example, when we observe the points being emitted, they appear as individual dots rather than a continuous pattern. As you move your hand, the output will follow your movement to that specific location. When the output is slow, you can see distinct points. When it's fast with a maximum setting of 1000, the points connect together to form a cutting edge. This is particularly relevant for aesthetic surgery operations. If the speed is too fast, it becomes challenging to control. Adjustments should be made based on the physician's preferences and required power levels. Understanding end time. The end time refers to how long a beam stays at one position. Longer exposure causes more diffusion of light beyond that point. The longer the laser end time, the larger the point becomes. Thus, a larger value results in a thicker point. When this value is small, the point remains relatively fine. So even if the cutting tool creates thin lines, a larger value produces wider cuts. This is how end time can be adjusted and controlled within its range. The slow mode can be utilized with this head set to F equals 100 during operation. When removing or installing this head, it's crucial to ensure that the blue aviation connector at the back remains attached. This must not be removed. Now let's proceed with using this head for demonstration purposes with repeated pulses. Repeated pulses. This means multiple points will be emitted simultaneously. In contrast, single pulse means only one point will be emitted. Even if you keep pressing the foot pedal continuously, only one point will appear until you press it again for a second point. Continuous pulses refer to when it acts as a cutting tool directly without needing many other adjustments. Only power needs to be set. Now let's demonstrate multiple pulses at 10 watts while keeping everything else at 0, since those settings do not require adjustments. As we initiate this demonstration with multiple pulses, we will see it flash continuously at one point. We can hear the sound produced by this output. It consists of individual points forming multiple pulses. Each point represents one pulse, therefore, when selecting single pulse mode, only one point will be emitted after pressing once. If you continue pressing without releasing, no additional points will emit until you press again for another output. Now let's look at continuous pulses at 10 watts of power. Other settings remain unchanged and do not need adjustment. The continuous pulse has already cut through completely without further adjustments needed. Thus, what we need to focus on now is understanding multiple pulses or repeated pulses clearly. Once these settings are configured correctly, we can access the corresponding folder for further actions. We will first discuss Pulse 2. In Pulse 2, we begin by looking at the interface. Energy frequency levels. Low, medium, and high are displayed. If it shows 0, it means no action is needed. Single pulse versus repeated pulse. Let's first examine the single pulse. As the name suggests, there is only one pulse point. For a single pulse, starting values are as follows. Low starts at 10, medium at 25, and high at 40. You can adjust the energy according to your needs. The frequency can be adjusted up to a maximum of 1000 for lower settings, providing a broad range of adjustment. Frequency protection feature. When energy is high, the hertz cannot be adjusted as quickly. At the lowest frequency setting, the maximum hertz can be adjusted to 500. As the energy increases, the frequency will decrease accordingly. Hence, we don't need to adjust the frequency too quickly. Frequency is mainly relevant during repeated pulses. For single pulses, we focus on adjusting energy and activating the device. Now let's look at the red aiming point and its energy output. When I press the foot pedal, it emits a single burst of light. This is low energy and not visible. As long as I keep my foot on the pedal, it does not continuously output energy. We can increase the energy slightly to see that when it's higher, we can observe the output from this energy point. Pressing the foot pedal once will produce just one burst of energy, regardless of whether I release it or not. Thus, only energy adjustment is necessary. Switching to repeated pulses allows for multiple small points to output energy simultaneously. The frequency controls how quickly these bursts are emitted. A higher frequency makes them appear continuous like a cutting tool. Now let's try this at 20 watts while using only the foot pedal switch to control output. In one location continuously, we can't see it, but its energy will penetrate as we move smoothly across the surface. At a frequency of 1 Hz, we see that it operates relatively slowly. Increasing the frequency to 10 makes it operate faster. Once familiar with these settings, you can use them for vaporization or carbonization based on your required energy and frequency adjustments. The 3 levels, low, medium, and high, can also be adjusted according to your needs. Now let's discuss Pulse 3 mode. In Pulse 3 mode, we also have the options for single pulse and continuous pulse, which is the same as repeated pulse. First, let's take a look at single pulse. For single pulse, we adjust the values in the second row, not the first row. The second row is where we can make adjustments for single pulse settings, while repeated pulse adjustments are made in the first row. Now, focusing on single pulse, we refer to the settings in the bottom row. The output energy is determined by multiplying pulse width by power. So, pulse width multiplied by power equals output energy. Let's do a simple test with single pulse. As the name suggests, single pulse means outputting a single point of energy, just like before. When I keep my foot on the pedal, it does not emit a second burst of energy, it only produces one burst. This is what single pulse means, it outputs just one pulse. In contrast, repeated pulse means multiple pulses of energy are emitted. While I continuously press the foot pedal, we can see that the energy output is still quite strong. Based on our needs, we can adjust its intensity to make it weaker. As we reduce the energy, we can observe that it becomes less penetrating. The gynecological treatment involves 3 operational heads, all of which require connection through a speculum. First, let's look at the harpoon operational head. After connecting it, you need to remove the golden part. We start by taking off the air tube, then rotate the golden head to detach it. When removing it, be cautious and take off the needle tip as well. After that, we will use the speculum. And need to fit the handpiece accordingly before attaching it to the fractional operational head. You must not insert the handpiece directly. It must first connect with the speculum. We should align the screw threads carefully while connecting. Now, let's check the focal length. It will enlarge the light beam when activated. At this point, regardless of energy levels, we will first test in private mode using the harpoon, with a circular output shape on a flat plane. If we switch to internal use, there is a steel frame for the internal handpiece that we will fit into the female vagina. This handpiece can be adjusted between 90 degrees and 360 degrees by rotating it accordingly. You can see that it has been rotated out. I won't replace it just yet. After activating the private mode, you will notice a red aiming light appears once we start working. The red light within 2 to 3 millimeters is considered normal. We can simulate our operational position next. To simulate, we will use an A4 paper at a capacity of 25 watts. Let's lower it slightly to 20 watts and set it to 1.03 milliseconds. We wrap the A4 paper tightly and then adjust our movement according to this scale bar. As we move according to this scale bar, you can observe that the points are spaced parallelly. If we increase our range of movement, the points will be more sparse, while a smaller range results in denser points. This paper will not allow energy penetration, so we adjust based on what the doctor requires for energy settings accordingly. Now let's enter private mode. In private mode, we access it through the pulse modes, pulse 1, pulse 2, and pulse 3, specifically entering from pulse 1. Once inside, we look for GYN, which is the abbreviation for private mode. At this point, we don't need to worry about the other settings for continuous pulse, repeated pulse, or single pulse. Power settings, we select the power intensity based on what the operating physician requires. Start time, the smaller the value for start time, the lower the power. Conversely, a larger value indicates a longer stay time, measured in milliseconds, ms. We can set this value to be smaller or larger, with a default of 1.0. For example, at 15 watts with a 1.0 stay time, the output is quick and shallow. This results in a minimal impression on a piece of paper, just a slight mark. When we increase it to 3.0, we can clearly see that the intensity is stronger. Previously set at 3.0 for end time, if we adjust it to 10, the end time value increases as well, leading to longer exposure. As the end time increases, the points become slightly thicker compared to before. If we increase it even more, they will become thicker still, resulting in larger wound areas. Thus, adjustments should be made based on the operator's preferences regarding energy parameters and stay times. With this setting at its maximum, it can penetrate through 4 sheets of paper completely. This translation is approximately 290 words long and should take about 2 minutes to read aloud at a normal pace. If you need further adjustments or additional content to reach a specific duration, please let me know.